Hey everybody, this is Larry. This is me going with Q3 of the Leetcode Weekly Contest 211. Best team with no conflicts. So this one, there's a little bit of reading and wording, but the idea is, you know, the TLDR is longest path in the DAG, kind of, but basically it becomes dynamic programming, and it's one of those cases where I wish I did it top down. I think I've always done longest path in the DAG bottoms up, and that's why I had a little bit of an issue. But the idea here is that, okay, so first you have to sort it by the scores first and then the age, right? Why do you need to do that? Because then you it's kind of like a topological sort where if two people have the same score, then they have to your assumption is that if a node, if a person is older than the previous person, then you see that chain where then that person has to be older than their previous person and so forth, while the score has to be the same way, right? So in that way it is monotonically increasing. So that's why we just sort it by the scores and then the ages, and then it becomes a like I said, the longest path in the DAG kind of dynamic programming problem. Once you do that, you go, okay, for every node, I think I print something here. So okay, and then now from that, let's say we consider this character, right? Well, we look at it. Can this be added to the same team as this person? The answer is yes if the age is greater and the score is, or the score doesn't really. Well, I mean, you're sorted by the score, right? So that that's going to be true. So if the age is the same or greater, then that this could be on the same team as this person and all the teams that they'll be in, right? Because this is, as I said, monotonically increasing or decreasing, how you want to call it. That if this person is able to play with this person, then this person is also be able to play with all the people that this person is able to play with. So there's this transitive property type thing here, which also is a DAG-E thing. But once you kind of understand that, then that means that you always want to choose the latest person that you get. Oh, well, not the latest, but one that gives you the most score. And that's why we do a max over that, right? So basically, for each so we ask, is this person if this person can play with this person, then we take the best score of 5 plus whatever the best score that the best team this person's score has, right? So what I did it the prefix way, where I'm going backwards. You could do it forwards. I think it's roughly the same. I mean, other than your if statements, but yeah. And once you've done that, basically what the thing that I always ask for my dynamic programming, I'll kind of write it top down a little bit, which is that for a given index, we go, okay, for x is in range of index, meaning from 0 to x minus 1, best result, the max score is equal to max of the best of x plus the current this person's score. I mean, I'm not using, this is not real code, this is more like pseudocode, right? And we only do this if this condition hold, which is that score sub x is, was it less than score sub index, and ages of index is ages of x. Oh, I got it the other way. Whoops. Something like that, right? I think the scores has to be strictly something, something like that. I'm hand wavy a little bit. You could kind of prove to yourself that this is going on, but then we take all the best cases, and that's how you get the answer. Little hand wavy. This is my code. if you do have trouble understanding this, then I recommend look up like longest path in the DAG solutions, and that's how you could kind of think about it. Yeah, that's all I have with this problem. Let me know what you think. I made a couple of mistakes because I was during the contest because I was silly and I was thinking of another problem, and I think that threw me off a little bit. If I had done the top down, I probably would have gotten it right the first go. But sometimes here, right? I think for dynamic programming, you have to ask yourself precisely what is the question you're asking, and I didn't do that. I think because I recognized this as a problem that I've done in the past, I went, okay, I know the pattern, let's go, right? Where I think if I spend an extra minute just like thinking about the exact question, then I will be able to like to answer that question. And what I mean by that is that this is get the best team score with the last person added at index. Yeah, right. With the assumption that the scores and the ages are sorted, right? So if I have that, then this would be way more forward because I had some weird thing. You could watch in the video afterwards as I kind of go on, and you could see what I made WAs on, but. And this applies for recursion really easily because you can kind of see what it is here, and but you can also, it's the same for here, right? Which is for the DP array, DP sub index is equal to the best score. So you have to ask the same question, and I think the question that I asked was the wrong one, and I solved the wrong one because it changes the transitions and stuff like that, because it's basically if you want to. This is just me kind of showing you how I learned what I did wrong by accident and how I debug it, and you can see me live doing that. Is that my question was the best team score with any person added before index. So that was kind of how I answered it, and the transitions didn't really make sense as a result of that because in this case we were saying that the last index, the last person. You have this like monotonically increasing thing, right? Chain if you do the longest path in a DAG interpretation. But if you do any person, well, that case is no longer true, right? Because for example, just because 10 is, let's say 5-3, you put the best score. Okay, this is not a good example for this one. So let's say we have, I think I had one because I had a WA from it, so I know this one. But give me a second. Let me pull up a good example because it's a good example because I got a wrong answer on it. So this one. So what happened, and you can watch me debug it live, is that when I ran this, is it this one? Yeah. Is that when I saw the 7-1, because we want to get the best score, so the best score here is going to be, maybe another one. So 4-2, right? So the best score here is going to be, this connected to this 3-1, right? And 4-2 has no connection to 3-5, but because we have any person, we took this prefix, so then this gets the best score here, right? But now, because of that, if this score 4-2, if we do that transition, then that means that 7-1 is connected to 3-5 because of how we did this edge, and that's just not right. So basically before, because I did any person, one way to kind of roll that up is to kind of make an edge from this node to the node before. But again, but that doesn't make sense in this context, because in this case, you do this, if you think about it transitively, 7-1 now connects to, 7-2 now connects to 4-2, but 7-2 cannot take the best answer from 3-5, right? So that was my bug, that was my interpretation. And this is why, like, when I talk about dynamic programming and memorization and stuff like that, I always ask you have to be very precise into what kind of question you ask yourself, because then you write your code in really, really small, minutely different ways that affects the outcome. Because my answer, my given this answer, it was right for enough cases that I submitted, right, twice. Otherwise, I wouldn't have, because I'm not giving up 3 minutes here on things that I know to be wrong, right? So, but because I just couldn't figure it out, that was the case. But yeah, and once you kind of be really precise on the definition, then you're able to solve it. And sometimes, at least for me, because I have that experience, I rely on intuition and my gut a little bit too much because I've done a lot of these problems, similar problems in different ways. So I end up trusting myself, but sometimes a little bit too much. Anyway, the complexity should be straightforward. The number of states here is O of n, meaning that the number of possible inputs is n. And in each of these, we do an O of n loop to find the answer. So this is going to be n squared. And you can see this in this loop as well. There are 2 loops, the n squared. The space is actually O of n because I just, there's only one dimension. But so O of n squared time, O of n space, and that's the complexity of this problem. Again, you can watch me solve it live during the contest with mistakes and all. Right about now. I have to press the button. Times out would be a little bit sad. So n is 1,000. Okay. Then older player. Okay. Are these sorted anyway? Nope. I have to sort them first. Ages of J. Is equals to A. The opposite of this, right? And square sub J. Oops. This is not right because I have to sort. I don't know how to sort. Oh, did I mess up? Oh, I might have messed up this one. how to sort this. Also, this is just well. Wait, did I mess it up? Oof, I did mess it up. Yeah, okay. Mess up some base conditions. Scroll plus read this one. Okay. So basically it has to be, did I do it by score or the other one? Let's see. In this case, it's the highest score. This will have to be greater than. Oh, phew. I wasn't confident on this one, to be honest, but it's greedy. It's the right algorithm, but it may but maybe in the wrong dimension, which is why I wasn't sure. Okay. Because this is the age. So what happens when you have to score? This means that now this score is true. So now this is the age. Okay. This is the score age. Not right either. To choose the first 3 players. My first intuition is closer, but I just had a equal case. Still wow. Okay. I'm just trying too much. I gotta prove it. In this case, you have this and 16. How do we even get 11? Oh, 6 and a 5. Let's just strip the gray. Oh. I don't know anymore. If the score is strictly higher, no, this should be good, but then this gives me a wrong answer on this one. Right? Why is that? It's too hard to eyeball. Okay, 3, that's fine. 10 and the 7 could definitely play together. These could play together. What? Where is the 29 coming from? So these are 5, 9, 24. Wait, what? 9, 14, 24. So that's not good. I'm missing something. So this is 1, 2, this 5, that's good. 8, this is good. 9 is because it goes to this. That makes sense. 5 and 4 is this, so that's 14, so that's good. Oh, but you can have, is that true? No. At 7, 1, we have to go all the way back to here. So there should be 12, maybe. How did I get 17? Oh, 14, because this is Oh, because I did the thing with the prefix. Okay, fine. I was trying to be clever, but I think I messed up as a result. I think I was thinking of something else. Was it 16? I was trying to be too clever. Hey, thanks for watching this video. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and let me know what you think about this contest, this problem, and so forth. And I will see y'all next fall. Bye bye.